So, uh, this is the outline of our today webinar. First, we'll have an introduction of QI, then our speaker, then we have a discussion on our agenda, then QI accreditation process. So, QI Quality and Accreditation Institute is India's second largest accreditation body, which give accreditation as per the various standards, whether it could be ISO 15189, 17025, and other standards. So, QI, our Dr. Bhupendra Kumar Rana is our founder and CEO. He has been over 25 years of his experience in quality, standard development, accreditation, and patient safety. He was earlier associated with the NABH as a director and CEO in charge, Quality Council of India, where his visionary leadership transformed the healthcare quality framework in the country. He is a founding member of International Academy of Quality and Safety, member of Scientific Advisory Board, International Alliance of Patients and Organizations, Vice Chair of the Mutual Recognition Arrangement (MRA) Council of Asia Pacific Accreditation Corporation (APEC), former board member and chairman of the Accreditation Council of International Society for Quality in Healthcare (ISQA), international expert of World Health Organization (WHO), the World Bank, Asian Development Bank, and the United Nations Framework Convention on Climate Change. So, as I earlier mentioned, QI is India's second largest accreditation body. So, QI has some visions and values and missions. So, we have a vision to nurturing the largest global pool of merchants and people through quality framework, quality improvement, and accreditation framework. We have some values. We are good listeners. We always seek continuous feedback from the stakeholders to address their concern. We are competitive. We look for viable options to benefit users of our services. And QI has adopted transparency because whatever our policies, they all are available in public domain. We are innovative. Innovation in terms of standards which we have developed in total our journey, because more than 20 number of standards we have developed as per the customer query and feedback. So KI having a mission to conceive, deliver education, training, accreditation, and related program in partnership with various stakeholders using an approach of co-design and co-creations. So initially QI started its journey in August 2017, and we are EPIC and ALEC MRI signatory for medical testing as ISO 189 and testing and calibration as per the ISO 17025. So let's thoroughly go about QI structure. QI having a four verticals. First is Center for Education and Training, under which we do offer training as per the different standard, whether it could be ISO standard or other healthcare standards. Then we have CHSC, Center for Accreditation of Health and Social Care, under which we do offer accreditation for the healthcare service provider, whether it could be hospital, clinic, heart and IVF centers, or vision centers. Then we have CIA, Center for International Accreditation, formerly known as the Center for Laboratory Accreditation, under which we do offer accreditation as per the various ISO standard. Then we have Center for Accreditation of Veterinary Facilities, under which we do offer accreditation for the veterinary facility providers. So let's thoroughly go about our CAA program. We do offer accreditation for the medical laboratories as per the ISO 15189 standard. We also do offer a certification for medical laboratories as per the requirement of Central Clinical Establishment Act. We also do offer accreditation for the testing and calibration laboratories as per the ISO IC 17025 standard. We become first body in India, those who offer accreditation for the biobanking as per the ISO 20387 standard. We do offer accreditation for the process testing provider as per the ISO IC 17043. We also do offer accreditation for the inspection bodies as per the ISO IEC 17020 standard. We do offer accreditation for the reference material producer as per the ISO 17034 standard. So for CIA program, we have international recognition. As I earlier mentioned, we become a full member MRA signatory of Asia Pacific Cooperation APEC. We also a full member MRA signatory of International Laboratory Accreditation ILAC. So these are APEC and ILAC, these are the global body, those authorize any of the accreditation body in the world. So our CIA program is accepted by Bureau of Indian Standard. If you visit BI's website, they have clearly mentioned all the accreditation body in India on their website. Our program is also recognized by Eastern Railway, Central Public Works Department, Directorate General of Quality Assurance, Power Finance Corporation, Coal India Limited, Legal Metrology Department of Consumer Affairs, National Highway Authority of India, Military Engineering Services, Power Grid Corporation of India, Bureau of Energy Efficiency, Rights Limited, Public Works Department, MP Government, BHEL Bhopal, Directorate Urban Administration and Development, MP Bhopal, National Building Construction Corporation. So these are the number of accreditation which we have given as per the different, like for testing laboratories, we have given accreditation more than 153. Labs, medical, we have 31, calibration 5, biobanking 4, PTP 2, RMP 2, and inspection body 1. And this is the yearly accreditation. Like in 2025, we have given 91 laboratories accreditation, and total 2025, we have accredited to 240 laboratories. This is a golden seal of mark of QAI accreditation, which we offer to any testing or medical laboratories, those who successfully complete QAI accreditation process. So we have a geographical presence, not in India. We are not all limited to India. We have global presence. We have presence in Bahrain, Bangladesh, Ghana, Maldives, Mongolia, Morocco, Myanmar, Nepal, Qatar, Lebanon, Bhutan, and UAE. So our today webinar will take care by Dr. Yogesh Chandra Nijavan. He has experience as a director, National Test House, Ghaziabad Subordinate Officer of Ministry of Consumer Affairs, over 30 years of experience. Uh, Also, Chief Director, Director of Vanaspati, Vegetable Oils and Fats, Government of India. So earlier he has been associated with Government of India. In accreditation activities, he is associated with QI as a lead assessor and faculty for training program. Also associated with other accreditation body for more than 25 years. And he has audited more than 500 testing laboratories as per the ISO 17025 standard, ISO 17034 standard, and ISO 17043 standard, and also for the biobanking as per the ISO 2038 standard. He was also a central committee member for the NABL, EPDA, FSSI, and BIS. Thank you. This is all about our today's speaker. So I welcome Dr. Faisini Jawan sir to take forward. Welcome, sir. Sir, am I audible? You can share your PPT. We can start. You are on mute. Please unmute yourself.
Yeah. Okay. So just I will share the. So this. So good evening. I'm Dr. Vaisin Jan. Welcome to QI webinar on ensuring metrological traceability in testing and calibration labs. Practical approaches to ISO IC 17025 2017 compliance. So as you know, participants, you must be either from the testing or calibration lab. So there is a requirement of metrological traceability in ISO IC 17025 as per the clause 6. So whether it is a testing lab or calibration lab, the results which are generated by the laboratory, they should be metrological traceable. So whether it is through the instruments that is being used for testing or calibration, or by using the reference standard. So that is the approach for ensuring the metrological traceability. So we'll cover how the metrological traceability can be achieved, and how it can be demonstrated, and what are the various concepts that is connected with the metrological traceability. Uh, so the definition of metrological traceability, as we know, that metrological traceability is defined as the property of a measurement result whereby the result can be related to a reference through a documented, unbroken chain of calibrations, each contributing to the measurement uncertainty. So whatever the results that is being generated, that should be traceable, uh, and which can be documented through unbroken chain of calibration, either through calibration of the instruments or through the reference standards. So the laboratory which is using that instrument, where that instrument has to be calibrated, and which can give that traceability through an unbroken chain of calibrations. So in a simple term, it ensures that the result produced by a laboratory is accurate, comparable, and internationally accepted. So once the traceability has been established, so when the laboratory ensures that the results that is produced by them is accurate, because the purpose of material traceability is to give the to ensure that the whatever results they are producing is as per the requirement of the 17025 of the metrological traceability. So the importance of metrological traceability for the various laboratories to ensure that the results are reliable and accurate. Facilities, it facilitates global acceptance of data. So whatever the results that is being generated, since the lab is accredited as per the requirement of 17025, so it automatically the results that is being generated by them acceptable by the other laboratories or other organizations, whether it is within the India or outside the India, which are the as per the ILAC MRA. So whatever the laboratories or the accreditation bodies that is under that MRA, they accept those certificates by ensuring the metrological traceability, and it builds customer confidence. So it automatically the customer's confidence is built, because the purpose of the laboratory, whether it's a testing or calibration laboratory, is to give the service to the customer. So then it helps demonstrate technical competence of the laboratory. The persons who are working, that also has the confidence in their competence, that it supports the regulatory, legal, and customer requirements. So the all these requirement is also for the regulatory requirements are also there, and the legal and the customer requirement are also ensured. So the it demonstrates compliance with ISO IC 17025 for clauses as requirement for the clause 6.4, 6.5, and 7.6. So these are the importance of metrological traceability. Then the what are the different elements of metrological traceability is through the reference standard, which are traceable to SI units, unbroken chain of calibrations, measurement uncertainty evaluation, competent accredited calibration bodies, and documentation. So these are the key elements of metrological traceability which the laboratory has to maintain with them to show the metrological traceability in their working. So now I will go in detail the various key elements. The metrological traceability requires First, a reference standard. So the reference standard, so it is through the reference standard that the material testability can be established by the by traceable to SI units. To the SI units are meter, for example, meter, kilogram, second, that will cover in the subsequent slides, the various SI units. So the certified reference material that is being used also gives the traceability. If the instrument's direct calibration cannot give the traceability, then the certified reference materials are used for the traceability. So especially in the various testing, especially in the testing, whether it's mechanical testing or chemical testing or biological testing, or so the whatever the certified reference material that is being used, those reference materials should also be traceable. Then that traceability can be established by national or international standards. So the various standards that is maintained by through NPL or which is our national NMI, and NIST, that is of the American uh, agency. So there are 7 base units on which all other units and quantities of day-to-day measurements are based. So basically, there are 7 base units of SI units. So the other are derived units. So but the purpose of metrological traceability is to establish traceability through SI units. So the subsequently it can be derived, but the traceability is always through the SI units. So the definition of these 7 units are the responsibility of the BIPM, CIPM, and CGPM. So these are the international bodies which maintain the uh, primary national, international standards with them, who are responsible for those maintaining the various reference standards. The base units are a choice of 7 well-defined units, which by convention are regarded as dimensionally independent. So these are the meter, the kilogram, the second, the ampere, the Kelvin, the mole, and the candela. So these are the basic 7 SI units which are used internationally. So the derived units are those formed by combining base units according to the algebraic relations linking the corresponding quantities. So like in the case of the meter, the for the distance, so it can be kilometer, or it can be the centimeter or millimeter. So those are the derived units. Or in the case of weight, we use gram, milligram, microgram, milligram. So these are the derived units. So then the names and symbols of some of these units thus form can be replaced by special names. So those the derived units have their own you can say unit, the various symbols that is being used, and symbols which can themselves be used to form expressions and symbols of other derived units. So the SI is not a static byte, but evolves to match the world's increasingly demanding requirements for measurement. So as there is increasing development are occurring, so more units are derived or it can be used depending on the requirements. So then comes the unbroken chain of calibration. So the unbroken chain of calibration is each step must be linked to higher order standard, ultimately reaching the SI unit or an accepted reference. So the unbroken chain of calibration is that there is primary standard international body which are keeping the primary standards like the CIPM or BIPM. So they are responsible for that particular primary standard. So with those standard, the other NMI are associated. So they have got MRA with them. So those standards which are being taken care by those NMI of various countries, they are traceable to the primary standard, and the NMI of that country is then subsequently linked, or it is then having linked to the other calibration lab, or you can say the calibration laboratories which are getting uh, their primary or the secondary or working secondary standards calibration from NMI, like we have NPL, and are from the other calibration lab, the second calibration lab, which is having the traceability to NPL. So there is a chain of uh, unbroken chain of calibration, and that calibration lab then subsequently do the calibration of the testing lab or the calibration lab. So there can be in between there can be two labs, or maybe through three labs, but their linkages should be continuous. So each step must be linked to higher order standard. So subsequently, the lab which is getting a calibration from a calibration lab, that must be linked to the higher order, means more closer to the NMI, means to like the NPL, which is of that country, or directly if they can not only nationally, they can also get it from internationally calibration lab also. So reaching the SI units are an accepted reference. So these are the basic SI units, seven of various measurements. For the length, it is meter, and the symbol used is M. Then mass, kilogram, kg. Time, second, S. Electric current, ampere, A. And temperature, thermodynamic temperature, Kelvin, K. Luminous intensity, candela, CD, amount of substance, mole, and MOL, mole. So these are the basic SI units that is being used internationally. So the traceability chain, for the traceability chain, we take example of the mass. So in case of mass, like the sequence of measurement standards and calibration that is used to relate a measurement result to a reference. So it is related to a particular reference or the standard, which is being like here in diagrammatic. The first one is like it is being the primary standard is maintained by BIPM, International Prototype of Kilogram. That is meant of it is made up of platinum iridium. So it is maintained by BIPM. So with the BIPM, the primary national standard, that is the National Metrological Institute of various countries, that is being maintaining or is traceable to that standard of BIPM. So they can either of the same platinum iridium, or it can be of stainless steel. So that they maintain is maintained by NMI under particular temperature and environment, particular environment they have to maintain, and that has to be continuously controlled. So it has to be kept at a particular temperature, humidity, and various other factors are being used for that particular environment. They are maintained, they are kept. Then the secondary standard, which is being used by them for the various calibrations by using the secondary standards, which is traceable to the primary national standard of that NMI, or they can use, they can also further make working standards, National Meteorological Institute, so that of stainless steel of various you can say quality. So then finally the calibration lab also has their standard, which is being calibrated by the NMI. So that is National Meteorological Institute. So that they also make the working standard. So there is continuous unbroken chain of calibrations uh, from one place to another, then from one calibration lab to another, or through directly through NMI. So the for the further the further your measurements are down in the traceability chain, the higher the uncertainty of the measurement. So the more number of labs that comes in between, when a lab testing or calibration lab gets their instrument or their reference standard calibrated, so the more the uncertainty gets added. So if there are suppose uh, 3 or 4 labs, or so every lab the uncertainty will be there. So that will add continuously. It will be added to the final outcome of the uncertainty of that standard of R for that instrument. So the it is always better to have a less you can say the uncertainty of that instrument being used by the lab. So there should be less number of calibration labs in between. So the preferably we will see in subsequent labs. So what should be the criteria of selecting the various labs. Then we comes to the establishing metrological traceability, how it can be established. Metrological traceability is established by considering and then ensuring the following. So these are the following are the some of the points by which the laboratory can ensure metrological traceability, either it is testing or calibration lab. The specification of the measurement, that is quantity to be measured. So that first we see the what is the measurement, a documented unbroken chain of calibration going back to stated and appropriate references. Appropriate references include national or international standard and industry standard. So that whatever the laboratory is ensuring the calibration, so they should maintain that how they are that unbroken chain of calibration is there. So that should be documented through the calibration certificates which they get, the information that is given in the calibration certificate, and by getting the various information in the certificate, they have to document those things. That measurement uncertainty for each step in the traceability chain is evaluated according to agreed methods. So the laboratory should ensure that that uncertainty, whatever is given by the calibration lab, how they have given through their masters, which is being used for calibration of the instrument of that lab. Uh, so those masters which are used, their uncertainty also has to be mentioned in the certificate, so that they can be ensured that they have given all the information related with the traceability in the certificate. So that each step of the chain is performed in accordance with the appropriate methods. So whatever the methods that is being used by the calibration lab, that should be appropriately mentioned, what methods that is being used with the measurement results and with associated recorded measurement uncertainties. So the calibration lab uh, gives all these details of the traceability of their masters, the uncertainty associated with various parameters that is being calibrated, the uncertainties of that parameters of each parameter. So that the laboratory is performing one or more steps in the supply chain, evidence for their technical competence. So that the laboratory which is performing the calibration, they also has to give the evidence of their technical competence, that they are technically competent, that is they are accredited as per 17025. So the systematic measurement error, so sometimes we call it as bias. So if there is systematic, we have to consider, we have to see the calibration lab which is doing the calibration has to see the measurement error, that is systematic measurement error, also in the calculation, which is sometimes called the bias of the calibrated equipment, is taken in account to disseminate metrological traceability to measurement results in the laboratory. So there are several mechanisms available to take into account the systematic measurement errors in the dissemination of the measurement metrological traceability. So this is the way how the metrological traceability is established. So we will not cover this one. We'll move to the next regarding demonstrating metrological traceability. So how the metrological traceability can be demonstrated by a lab. Uh, so there are so many ways of demonstrating the metrological traceabilities. First is the laboratories are responsible for establishing metrological traceability in accordance with this document, that is 17025. So laboratory has to establish the regarding the calibration results from laboratories. So it is with respect to the calibration results from laboratories conforming to this document provide metrological traceability. So that is the requirement first for the calibration lab, that they which are whatever those calibration lab provide the metrological traceability. If it is a testing lab, to testing lab. So the calibration lab, so as I have discussed, that they have unbroken chain of calibration through to the secondary lab, calibration lab through their standard, or directly through the NMI. Then by using certified values or certified reference materials from reference materials producers conforming to ISO 17034 provide metrological traceability. So in case of many cases where the traceability cannot be established directly through the calibration of the instrument provided by the calibration lab. So in that case, certified values of the certified reference materials are used. So in many cases in the testing, CRMs are used, especially in the chemical and mechanical testing. These various CRMs are used. So those CRMs which are used, they should also have a traceability. So those CRMs traceability is being used for demonstrating the metrological traceability by the testing lab. So those CRM should be produced by a reference material producers, which we call it as RMP. Those RMP should also be accredited as per ISO 17034, because they also have to provide the metrological traceability. So those CRMs are also one of the way of establishing the metrological traceability if the instrument that is being used is not directly calibrated, which gives the traceability. But in that case, CRMs are used for establishing the for demonstrating the traceability. So there are various ways to demonstrate conformity with this document. Third party recognition such as accreditation body, external assessment. So ultimately the laboratories which are doing the testing or calibration, so they have to meet the requirement of 70025, which are then accredited by the various accreditation body. So there is they have to demonstrate their metrological traceability during the assessment by various means, which we have already discussed, which can be established by various means. So the third party recognition is required, so that accreditation body like QAI then gives the accreditation, the certificate to that lab, that it is accredited as per ISO 17025. During that assessment, all these things are assessed, like the metrological traceability and other requirement of 17025, which will be many times the external assessment by customer is also done, or the self-assessment can also be done, which we call internal audit. So which will give a confidence to the customer also, and to the competency of the persons also which are working in the laboratory is also assessed. So that is the purpose of the requirement of 17025. So internationally accepted paths include but are not limited to the following. So these are the further additions that we'll see. First is the calibration and measurement capabilities provided by national meteorology institutes and designated institutes that have been subject to suitable peer review processes. So internationally accepted paths are, so first is the calibration and measurement capabilities that is provided by various NMIs, are such peer review is conducted. So they are having MRA with the highest bodies which are having the primary uh, standards with them. They are maintaining the primary standard like CIPM. So they have to have MRA with them, which we call it as CIPM MRA. That CIPM is an International Committee for Weights and Measures Mutual Recognition Arrangement. So in case of mass, that is the agency which is keeping the primary standard. So all those NMI have MRA with them to have a traceability of their standard, which is being maintained by NMI, which is traceable to the family standard internationally maintained by those bodies. Then calibration and measurement capabilities that have been accredited by an accreditation body subject to ILAC arrangement, R to regional arrangement, recognized by ILAC, have demonstrated metrological traceability. So the calibration and testing laboratories which are accredited by the accreditation body, they also should be having ILAC MRA with them, which the ILAC, which they can be demonstrated to the meteorological traceability is demonstrated to ILAC. So they are ultimately having MRA with the ILAC, and only those accreditation bodies are acceptable. So then the scopes of accredited laboratories are publicly available from their respective accreditation body. So these are the things that the various processes are being used internationally. That is, the first is uh, the primary standard being kept by a international body, then which is traceable to the NMI of that country is traceable to that one. That NMI is accredited by the accreditation body. The accreditation body should be having ILAC, MRA with the ILAC, and that accreditation body is also accredited on continuation basis. So that accreditation body then do the accreditation of the various calibration AB, or the various accreditation that AB does the accreditation of the various CABs, whether it is a testing or calibration labs or any other type of lab being. So now we see the various sources of traceability. So the what are the routes of traceability? According to ILAC P10 and ISO IC 792, traceability can be achieved via primary route. The first, which is the most preferred, through National Meteorological Institutes. That is NMI, for example, NPL of India, then NIST of USA, PTB of Germany. So these are the other NMIs through which the various traceability can be achieved. Then accredited calibration laboratories under ILAC MRA. So the various calibration laboratories which are doing the calibration, they also give the traceability. So it can be established through these way, either directly through NMI or through accredited calibration laboratories, which are under which are accredited by the accreditation body, which is having ILAC, MRA with the ILAC. Then secondary routes only if primary is not possible. Then the secondary route can be used by using CRMs from ISO 17034 accredited producers, which are providing the CRMs with the metrological traceability. So the CRMs, the laboratory should use CRMs preferably which is having metrological traceability, so that the metrological traceability can be established for their testing or calibration during testing or calibration. Then if the CRMs are not used, in many cases certified in-house standards only with adequate documented evidences that is being used. So in many cases the CRMs are not available, especially in the chemical testing, where the new products, if some comes, the CRMs are not available. So in that case, a certified in-house standard is being developed, so that can be then sent to the various laboratories to achieve a census value of that census value, which is then can be the can be used as a reference value, so that can be uh, then traceability can be achieved. So but that traceability, especially with the new molecule, especially in the organic molecules, which are very rare to get the traceability initially, so that can be achieved by using the various instruments or various things which is being used during the production of that CRM. So that, like the weight, the balance which is being used for producing the uh, CRM is having a traceability to particular meteorological traceability through unbroken chain of calibration. So that ultimately gives the traceability to the that particular CRM, that is which is being developed by either by RMP or by in-house standard. So sometimes these uh, things comes in the way by the various laboratories, testing or calibration laboratories, when new developments and new things comes up. So these are the other ways that indirectly traceability can be established by producing that CRM. So either through the various, that depends on the various method that is being used by the for producing, like in many cases not only the balance is used, in many cases in the chemical especially, some internal reference material is used during the uh, analysis. So that internal reference material uh, is traceable. If it is traceable, so that internal reference material which is traceable will establish the traceability of the main CRM which is being produced. So that way also traceability can be established. So there are the other ways also by establishing the traceability, like I've given these 2-3 examples. Then the this is the example traceability chain, that is the instrument which is being calibrated by the working standard, having traceability to working standard, the working standard then having traceability to the reference standard. That reference standard is traceability to national standard. So that national standard, which is being kept by NMI, is having traceability to SI unit of the primary standard. So this is the example of a traceability chain. Now we'll see the various requirement of 17025 2017, the clause 6.5, what it says. So it has got three clauses, three sub clauses: 6.5.1, 5.2, 5.3. So what it says, the same thing which we have covered, but we'll cover one by one. That the laboratory shall establish and maintain metrological traceability of its measurement results by means of a documented, unbroken chain of calibrations, each contributing to measurement uncertainty, linking them to an appropriate reference. So this is the same the metrological traceability definition which we have seen in the first slide. So this is the requirement of 17025, which the requirement is that the lab should establish a metrological traceability of its measurement results. Whatever results being produced by the lab, that should be traceable through by means of a documented unbroken chain of calibrations. Then the laboratory shall ensure that measurement results are traceable to SI units. So as we said that it should be finally traceable to SI units through a calibration provided by a competent laboratory. The calibration laboratory should be also accredited as per 17025. Then if it is not through calibration laboratory, then by using certified values of certified reference material provided by a competent producer, that is which is accredited as per ISO 17034 by a competent producer, which with stated metrological traceability to SI units. So that we have also seen. Then direct realization of the SI unit ensured by comparison directly or indirectly with national and international standard. So automatically it should be ensured that it should be compared with the national or international standard by SI units. So in case when metrological traceability to SI units is not technically possible, the laboratory shall demonstrate metrological traceability to an appropriate reference. For example, certified value, certified reference material provided by a competent producers. So it can be like I've given the examples. If it is not possible to give metrological traceability directly through calibrations or through reference material which is already established, then in that case it can be established through other methods that already have given the examples. So those by using various reference certified reference materials with known metrological traceability to SI units. Then results of reference measurement produce sorry. Results of reference measurement procedures, specified methods or sensor standards that are clearly described and accepted as providing measurement results fit for their intended use and ensured by suitable comparison. So in case when that CRM or that instrument traceability cannot be established directly, so in that case the reference measurement procedure that is being used, so during that procedure what are the things that is being used, like I have given that in many cases internal reference standard is used. So traceability of that internal reference standard is also linked to the main CRM which is being produced, which is not having traceability. So it can be linked to that this one, and then that CRM or the material which for which the traceability is being established, that can be then sent to the various laboratories to see the census value and automatically the reference value of that material. So by this way, it can be achieved. Now we see what are the requirements or what are the difference that metrological traceability in testing versus calibration labs. So what are the requirement and what are the difference now? For the calibration laboratories, must demonstrate traceability of all reference standard. So whatever reference standard being used by them for calibration, they must demonstrate its traceability. Then uncertainty evaluation is a major requirement. So they have to give the uncertainty measurement of each parameter that is being calibrated. Then for the testing laboratory, need traceability for measuring equipment influencing the test results. So whatever the instruments that is being used directly are the substrate equipment that is being used during the testing, like the thermometer, the volumetric flask, etc., or the you can say various other measuring like the tape or like these things. They should also be calibrated and they should also be having measurement metrological traceability. So must use traceable CRM for methods requiring reference materials. Where the method requires the reference material is used for the testing, those reference material, those CRM should also be traceable. Then uncertainty evaluation may be simplified depending on the method. So depending on the method, the uncertainty measurement is also calculated for the testing for the various tests which are quantitative in nature. So that for that the measurement uncertainty is being calculated. So these are the requirement of 17025 in various clauses where the metrological traceability is uh, is used, like in the clause 6.4 equipment calibration, where these things are mentioned, the metrological traceability and calibration, verification, and suitability. Then in clause 6.5 is directly related with metrological traceability, establishing and ensuring it. Then 7.6 measurement uncertainty, which is also linked to uh, the metrological traceability. Then 7.7 ensuring result validity through PTILC. That is where the reference standards being used, which is not having direct metrological traceability, but it is being established by a census value. Then evaluating and selecting instruments. So how the instrument calibration service provider can be selected. That evaluation has to be done while sending the instrument for calibration. All equipment used for measurement capable of achieving the required accuracy, having significant effect on testing or calibration results shall be calibrated. So all these equipment should be calibrated, which is having direct effect on the testing. When calibration give rise to any correction factor, the same is recorded and applied accordingly. So this is the case that in many cases, the calibration certificate gives the correction factor has to be applied. I give an example, a simple example of a uh, you can say mm, hot air oven. So in the hot air oven, suppose the temperature of that hot air oven has to be 105, for which the testing is being carried out, and the calibration lab has given the value of 105 uh, of the calibration. It has come to 108 or 110, suppose. So there is a error of 5 degree. That is mean the actual 105 is not, which is showing 105, is not 105, could not be achieved 105. The 105 can be achieved because as per the calibration it is 110. So there is error of 5 degree. So if that lab has to maintain the temperature at 105, they have to fix at 110. So they have to see that error or the how much error is there with respect to the calibration certificate, because you cannot achieve the 105 by fixing at 105. The however, the actual 105 is at 110. So they have to apply a correction factor. They have to write at the calibration certificate, and they have to mention that the person should fix that temperature at such and such temperature to achieve 105. So these are many times there is a lot of error in this one, and if the error is very high, then one should not use that equipment or instrument. It should be either rectified, it should be repaired, and get it calibration again. So don't use those instruments which are having very high errors or large errors. So that one has to see, and if there is error is within permissible limit, so then that case a correction factor has to be applied. So a calibration program and schedule are to be established for all equipments, including subsidy measurement equipment. So the lab should maintain a calibration program and schedule for their instruments, which has to be calibrated. All external calibration are to be done through the ISO IC 7225 accredited calibration laboratory, providing traceability to national or international standards and measurement uncertainty. So one should see that the lab calibration lab should be accredited, and then most important, check accredited scope of calibration lab before placing request order for calibration, and mention so the lab should get the scope of the calibration lab, whether they are accredited for their scope or not. Many times the calibration labs accept the equipment or instrument for calibration, but they don't have there in the scope, and they calibrate and give it to the lab without the logo. So that is then is not acceptable during the assessment, because that lab is not having that scope in their the accreditation. So one has to see whether it is in their scope or not, and mention required ranges to be covered for calibration. So many times the laboratories just send the equipment for the calibration without mentioning the ranges at which the calibration has to be done. So the calibration lab don't know the what are the working range of that lab, at which ranges it is using. So they do the calibration at as per their own wish. So but that is not then ultimately of use for the lab. Suppose the lab is doing the using uh, the oven, suppose at 100 degree, but the calibration lab has done the calibration at 130 degree or 50 degree. So it should be calibrated at that particular working range also. So the lab should, the lab which is sending their equipment or their instrument for the calibration, they should specifically mention that these ranges has to be covered for the calibration. Then we see the CRMs, the traceability regarding the CRMs, certified reference materials. So when producing CRMs, the metrological traceability of the certified values shall be established in requirements of ISO IC 17025. The RMP shall provide evidence of metrological traceability of the certified values to a stated reference. So whenever a lab purchase CRMs, they should also see, or they should purchase those CRMs only which is having metrological traceability and measurement uncertainty. has to be mentioned. Then only that CRM should be purchased, unless those CRMs are not available in the market. If these CRMs are available with material, then we purchase only these CRMs with the metrological traceability and measurement uncertainty. So a combination of results obtained by different measurement procedures and our laboratories are being traceable to the same reference is also traceable to that reference. So in cases where the different measurement procedures are being used by using a traceable CRMs, so in that case, if different CRMs are used, so in that case, the traceability is ultimately established through the reference material or the reference standard. Then the evidence can be based on evaluation of measurement process or on confirmation of material traceability, comparison of results with independent traceable values. So this is a case when it cannot be established directly. So in that case, a comparison of results with respect to independent traceable values, like given the example of balance. So it can be achieved through that uh, traceability by using various measurement process, that how the measurement is being done. Then clear identification of the property of interest, traceability of the numerical value and stated reference contribute to the traceability of the results. So ultimately, the traceability of the CRMs give the uncertainty measurements also. So those uncertainty measurements, whether it is through calibration certificates or through CRMs, those measurement uncertainty are being used by the laboratory for calculating the uncertainty measurement of their testing. So all these uncertainties are being used in the for measuring the uncertainty of the test results. So one has to see in total that the metrological testability has to be established. It should be defined in the calibration certificates, in the CRM certificates, with the metrological traceability and with the measurement uncertainty. So that should be ensured. So verifying traceability in detail, how laboratories establish metrological traceability, use of calibrated equipment. It's already mentioned that all critical measuring equipment must be calibrated at appropriate intervals. So there should not be gap in the calibration interval. So they should be uh, calibrated at appropriate intervals. So the lab should have a calibration program and schedule should be available with the lab. So calibration must be performed by accredited labs. Then use of CRMs. CRMs must be traceable to SI or internationally recognized references. Then material. So those CRMs which are being used, one should see two things I have already mentioned, that it should have a methodological traceability and measurement uncertainty, and the that certificate also should mention the material homogeneity, stability, and uncertainty must be documented. So that should also be mentioned in the CRM certificate, which is being provided by RMP. When the lab uh, place the order for the purchase of CRM, these things should be uh, ensured. Then internal calibration, if applicable. If in cases where the calibration, direct calibration cannot be get from the calibration lab, so in that case, internal calibration is done. So there are many ways of doing the internal calibrations, especially with the high-end equipments where the direct calibration is not being done. So the labs may perform internal calibrations only if competence is demonstrated and procedures are documented. Uh, so in that case, so I'll give the example like in the case of the instrument used in the chemical uh, GCMS. or GC, that is gas liquid chromatograph. So in that case, there are so many things that has to be calibrated, like the oven, the flow rate, the you can say the various uh, detectors. So the all these things, sometimes it can be calibrated by the calibration lab on site by using a calibrated equipment. But in some cases, it could not be possible uh, even by the calibration lab. So the testing lab does by using their own instruments, by doing the like the use of various CRMs or by using the various probes. So but those should also be calibrated with the traceability. So still requires external traceable references. So those references which are used for the calibration of that instrument, that should also be traceable. So many cases, but they are acceptable during the assessment. These things are acceptable. It's not that the whole instrument goes to the calibration lab and then it is accredited. Then it gets calibration. It gets so many parts, are the various zones which has to be calibrated. So some of them can be calibrated by the calibration lab on site, or some internally it can be calibrated. Then documenting traceability chains, that should be documented. A typical traceability chain that's already seen, that instrument, then working standard, reference standard, then national standard, and SI. Then in verification of supplier competence. So before accepting any calibration certificate, labs must check scope of accreditation. That's I already mentioned. The CMC, the calibration and measurement capability of the lab, then validity of the certificate, of the masters that is being used by the calibration lab, with their traceability and with their uncertainty and with their validity. These things also are mentioned by the calibration lab in their calibration certificate. That also has to be seen. Then whether the lab is having ILAC MRI logo or not. So it ensures that it is having international traceability. That as to, so these are the things that how the metrological traceability is established. Then we comes to there are many issues that comes up in the labs by which it affects the metrological traceability, or the lab could not establish due to certain issues which are like missing uncertainty values. Whenever they get the calibration from the laboratories, the uncertainty values are not given, are non-accredited calibration lab. Then in that case, traceability could not be established because that is not accredited, because it is a requirement of ISO IC 17025. Then expired CRMs certificates are used, or expired CRMs are used. Then poor documentation. The documentation is not proper. They could not establish the traceability. Then metrological traceability issues that can be avoided. There are issues which can be avoided by using calibration certificate without uncertainty, accepting traceability from non-accredited laboratories, using reference materials without valid certification. The the reference material is there, but the certificate is not available with the lab. Then not documenting environmental conditions of the or of the CRMs or the standards which is being used by the lab. So then extended calibration intervals without justification is there is break of calibration interval. Then depending on traceability by manufacturer specification without verification. So if the manufacturer has given the traceability or the certificate, but it is not uh, accredited or the without any verification is done by the lab. So many cases the manufacturer gives the, like especially in the case of glasswares, they give the certificate saying that it is A class or B class or so, and but in then it is not acceptable, because if that certificate, many manufacturers they have their lab accredited as per 17025, but some many suppliers their lab are not accredited. They supply this one but with a certificate, and the lab thinks that yes, that is okay, but many things are missing in those certificate. First is that certificate is without the ILAC MRA logo, that is it's not accredited. Then the uncertainties are not given, or the traceability is not given. In that case, those things are not acceptable. So lab has to see, and it should ensure that all these things are available whenever they purchase any instrument or any glasswares or any substrate equipments or any instrument. These things should be met, and these issues should be covered. They should not avoid these things. Then this is a calibration certificate review checklist, which the lab or the should make with them to check various things whenever they receive a calibration certificate, to ensure that all these things are available in the certificate, and the certificate is then acceptable. If these things are missing, then the lab should go back to the calibration lab. That so this is one of the few things which is the lab should make a checklist whenever they receive a certificate. They should check these things from 1 to 12, and they can add some more things if they wish. And with every certificate, this checklist should be available, like the which should contain name of intended laboratory or discipline, which discipline is sent, whether chemical, mechanical, or biological, or electrical. So then name and ID of equipment calibrated, then name of calibration laboratory and address, which is done, then order number and date of order, then date of calibration, then calibration certificate number, parameters calibrated, measurement uncertainty, environmental conditions, symbol of accredited body on certificate, evidence of traceability of measurement, then signature and designation of signing persons. So these are the things that the checklist should have, and a calibration certificate should be checked. Then finally we come to the conclusion that metrological traceability ensures that every measurement result produced by a testing or calibration laboratory is scientifically valid, comparable across borders, based on internationally accepted units, defensible during audits, and finally, metrological traceability ensures credible, comparable, and internationally accepted measurements. It is a key requirement of ISO IEC 17025. So we thank you. So we come to the
Thank you, sir. Thank you for your wonderful presentation. Before proceeding with the Q&A session, first we'll complete the QA accreditation process. Then after we'll take Q&A session. So Q&A session will take care by my colleague, Ms. Anuja Dixit. She's accreditation officer. So I welcome Ms. Anuja to take further.
Very good evening, everyone. Before we start with the accreditation process, I would like to introduce myself. Myself, Anuja Dikshit. I am associated with QAI, and I am designated as assistant manager under the vertical CIA. So we'll start with the accreditation process. Firstly, before starting the process, I would like to clarify who can apply for this testing and calibration laboratory accreditation. So, a testing and calibration laboratory implementing the requirements of ISO IEC 17025 is eligible to apply under this accreditation program. And the eligibility for this accreditation. What are the requirements for applying for this accreditation? The eligibility includes the applicant CAP must comply with all clauses of ISO IEC 17025. The applicant CAP must have participated satisfactorily in a proficiency testing program wherever applicable, and it should be conducted by APAC or any other national or international accredited or recognized PT provider. In cases where there are no suitable PT programs available, the CAB can initiate an inter-laboratory comparison with adequate number of accredited CABs or engage into other types of internal quality control checks. Also, the applicant CAB must have conducted at least one internal audit and a management review before the submission of application. Moving forward, what are the steps to achieve QAI accreditation? So, along with for submitting the application, the lab has to give the following documents. Our accreditation process takes place through mail. The lab needs to submit the soft copy of the complete application form. The application form is available on our website. Along with the application form, the lab also needs to submit few other documents, including the self-assessment management system documentation review toolkit, the soft copy of the quality manual or the management system documentation that is maintained by the laboratory, the prescribed application fees, which will be based on the scope that the lab will be applying, and also the signed terms and conditions document. All these documents are available on our website. Anyone who need all these documents can also send us an inquiry mail on this mail ID mentioned, that is info@qai.org.in. So moving on to the final process of our application. So firstly, the steps include filling of the application form. As I already explained in the previous slide, the lab needs to submit all these documents for applying for this accreditation program. So on the very first step, once we receive all these documents from the laboratory along with the prescribed fees, we proceed with the review and registration of the application. At the very first step, the scrutiny of the application is done by the accreditation officer. Then further, we move forward towards the document review and quality management system adequacy, which is done by the lead assessor, which will be appointed by taking consent from the laboratory. Also, the further step is pre-assessment, which is completely optional, whether the lab wants to have the pre-assessment or not. And once the document review is done and the lead assessor gives us a green flag to move forward, we move with the final scheduling of the final assessment. So final assessment is also scheduled by taking consent from the laboratory on the dates and the assessment team. And once this assessment is scheduled, further the assigned team comes to the laboratory for the final on-site assessment. Also, once the complete process is complete, the review report, the complete assessment report is submitted to us along with the necessary documents that are already with the assessors. So once we receive the complete assessment report, we proceed with the next step. The laboratory is given the time frame of 30 days to close the non-conformities in case the laboratory gets some non-conformities. Further, after completion of that, we also send a feedback link to the laboratory for any necessary corrective actions that are required. Then further to that, once all the things are closed by the lab and by the assessment team, we further proceed towards a recommendation for accreditation by the reviewer of panels. Further to that, once the review process of the complete assessment report is done, we move towards the final approval from our CEO. Then once we get the approval, we issue the final accreditation certificate. Also, once the lab is accredited, the accreditation cycle is of 2 years, and in between, we have a process of ongoing monitoring that is done in between of these 2 years after completion of 1 year. And before the end of this cycle, the lab needs to apply for the renewal before 4 months of expiry of their accreditation cycle. And also talking about the fee structure, our fee structure is based on World Bank's income level of classification for various countries. For details regarding to the fee structure, anyone who needs any query, any detailed fee structure or any query regarding to any process or any step, they can mail us on this mail ID. It's info@qai.org.in. Okay, that's the end of the accreditation process. I'll tell
Thank you, Ms.
my
Anuja,
colleague to take over.
for
Thank you so
your
much.
briefing about your introduction and process. So now we are open for your query and doubts. So anyone participant can have doubts, they can unmute yourself and ask from the webinar agenda or from the QAI accreditation process. So you may unmute yourself.
Hello. Good evening, sir. Tejas Patel. May I audible?
Yes,
Hello.
you're audible.
Yes, sir. This is regarding in ICP testing in inductive coupled plasma. We are analyzing the zinc bath analysis, right? For that, we are using CRM standards of MBH make UK make. They have certified the values of particular elements that this much element percentage are in the chips, and we are analyzing this CRM standard before testing of our plant sample. So if we get the ICP results for these CRM standards within the limit or slightly what they have permissible error defined before up and down side results before means what I say उनकी परमिसिबल लिमिट के थोड़ा भी बाहर है मतलब रिजल्ट्स हमारा आईसीपी का तो एडजस्टमेंट मतलब फैक्टराइजेशन करके रिपोर्ट कर सकते हैं उसमें सीआरएम स्टैंडर्ड में
No. Actually, the values which are given, because all these measurement are with respect to the standard. So ICP, you are using the standard. So that standard it's always comparable testing. So first you run the blank, then you run the
calibration.
Then you run the standard, then you do the calibration, and if your calibration is okay and your values, you get the linearity and other things you are getting, so then you run your
plant sample.
So when you are running your sample and if your results are not coming within the limit, that means there is something wrong with the sample, not with the standard. And you can check your standard also in between by using that standard of different concentration you make, and you treat it as a sample, whether you're getting the same value or not of that diluted sample or not. So that is also one of the way of cross-checking your reliability of the instrument and reliability of your results. So that is one of the way. And by using, as you say, that whether you can adjust or not, that is accordingly you have to make if there is any you are following some standard method, like some US EPA or BIS standard, or maybe US any other national or international standard. If they have given a particular value with the particular ranges, then it is okay. You have to satisfy that requirement. If it is not given, then in that case you have to use your own that we call it as uh, mm, uh, you have to make your own rule. Okay, so that rule you have to apply then. So
Means if we can we define rule as a हमने जो CRM स्टैंडर्ड में जो मान लीजिए 4% उन्होंने एल्यूमिनियम
yes, yes,
सर्टिफाई
yes,
किया है, तो उसका
yes.
3% हम लोग अलाउ करेंगे, मतलब
You
राइट
can
दैट
take,
लाइक दैट.
but with the respect to the specification. If the specification also allows that, you can say variation. If the specification doesn't allow, and that material is having, suppose I give a example of suppose some pesticide, okay, metals in some pesticide. So in that pesticide, if the limit given that it has to be plus minus, we count it as 10% or plus minus 20%. If it is going below that, over that or below that limit, then you have to think about that, whether it is meeting that requirement or not. And if it is not specified, if it is specified, you have to follow that specification only. If it is not specified in that, because in many cases which is specified, in that case the that is already inherent, that that rule is already inherent. So in that case you don't have to apply your own rule. So but if it is not given, then you can have your own rule, you can give that margin. Yes.
Okay.
That depends on the product to product and from specification to specification. Yes.
Okay. Thank you, sir.
Yes.
Good morning, sir. May I ask the question?
Yes.
Sir, I want to ask that for the review of calibration certificate, you mentioned 12 points. Those 12 points are more than enough for the calibration, right? For the review of
Yeah.
calibration checklist.
Yeah. Yeah.
Okay, like I don't need anything further beyond those 12 points, right?
No, you can add, means certain things that if you can want to see further whether the various uh, designation or name or these things are already I mentioned, but these are the most important and required points. But if you can add, it is up to you. You can add the things.
But I think it's more than enough. Otherwise, I think I'll complicate myself. Like the
Yeah,
once you,
yeah,
yeah.
yeah. Because these are the things which I have mentioned. It will cover most of the points.
Okay. Also, sir, I have one more question. Like the ma'am said something about the like if we can't find PT in some particular parameter or like product, but we can
Yeah,
do ILC for that. And ma'am mentioned that adequate number of labs. Like what is the adequate number? Like the minimum
yeah,
number is not mentioned in 17025. So I'm like,
yeah. It is not mentioned, but
yeah,
preferably if you get around say 10 or 12 labs, because it is then easy to calculate the Z score. Otherwise, if you have got only 3 or 4 lab, then you cannot make the Z score. Cannot. It's not easy to calculate Z score. And if some results are totally outlier, then again the number of labs will be reduced for calculating the Z score. So preferably, if you get at least minimum 5 labs, and preferably 10 labs are mostly appropriate if you get 10 labs, not less than that. Yeah. So the
and
interlaboratory comparison only is allowed where the PT program is not available, and you have find out from various PT providers. Many times that program is not available with the PT providers nationally. Then you have to search for the internationally PT providers. So
Yeah.
that you have to, yeah. Nowadays, especially in India, there are now so many PT providers are there. Earlier, there were very few, but now in India, maybe around more than 50 or I don't know the exact numbers, but they are in sufficient number. And you go to their website and check their annual PT program, because they give the annual PT program. If it is not on their website, you write to them, they will send it to you, their PT program, annual PT program, and then you register with them whenever they announce that program.
Okay, sir. Okay, sir. Thank you, sir.
Yes.
Hi, good afternoon, sir.
Yes.
I'm Kiran from Tata Consumer Product. So I
Yes.
have one question.
Yeah.
If I want to define in-house tolerance of any instrument, so how can I
Hmm.
define?
No, define the tolerance in which respect to it's because the whatever testing you name the instrument, because it will be better than to understand any
Okay.
instrument
For
which you are using.
example, weighing balance for
No,
calibration,
yeah, for
internal
weighing
calibration.
balance, yes. For weighing balance, when you uh, get it calibration from a calibration lab, they
Okay.
give the uncertainty measurement of each you can say weights. Okay.
Okay.
So of the balance they give that it has got this much uncertainty at that particular weight, and for this one at that particular weight. So then you do your internal calibration by using a calibrated weight box. Okay.
Yes.
So that weight box which you are using, it should be calibrated, and then you use the various weights for it. Then you see whether you are getting the within that permissible limit or not for that weight, and then you make your acceptance limit. Yes, it should be within this permissible limit with respect to measurement uncertainty. So that is the way, because you cannot for the balance it cannot be a one place, because it has got so many weights which are, and preferably you make do the calibration especially at least with one weight daily with one weight, and see whether it is, and with all the weights at least once in a month you do with all
Okay.
the weights to see for the whole range. But
Okay.
at least initially when you start the balance, you check it's zero, then you check the it's with one weight you check. If you can check with more weights or the working range. Suppose you are doing say within say 1 gram, you choose 1 gram weight. If you are using mostly suppose in milligrams, 500 milligram, 100 milligram, then you choose that weight, because that will be your working weight. It is always appropriate to check the working range, preferably daily, and for the whole range at least, depending on the use of the instrument, at least once in a month at least you do. And if the you are using equipment say after not regularly, then you can make the frequency quarterly or so, like that. So it depends on the use of the equipment and your working range. That is the appropriate.
Okay. Thank you. Again, one question. We are having a saffron commodity. So what happened? We are searching for CRMs. So we didn't get that. So how can we ensure that our results are proper, or we are getting that results are okay or not? So how can we define? No.
Saffron, Saffron CRM.
Yeah, for saffron, that is saffronal, picrocrocin, and crocin. We have
Yeah,
searched a
yeah,
lot. Yeah.
yeah.
So,
So I have already covered that there are so many methods that you can develop your own internal standard that you do. You have done so many analysis, okay, and then you it is better that if you can purify that material, if it is possible, you purify. Otherwise, you use that material and do the analysis number of times by using, if you have got different methods, use different methods, and then find out the results, that how they are comparable, and then find out its uncertainty also, and then you can send that material for interlaboratory comparison, okay, and
okay.
then that interlaboratory comparison, you get the values, you make a census value of that one, and that value will be your reference value, okay. So
Okay.
then that material you can use as an your reference standard, okay, but you have to establish those things,
Okay.
yes, by using these various methods, yes.
Okay.
Good
Yes. Thank
afternoon.
you.
This is Ganesh Patel. In continuation to what we were just discussing regarding reference materials, I'm also having the same issue. There are so many testing that does not have any CRMs.
Yes,
So, sir, what you said that we can generate our reference material in house and go for ILC and certify that values. Uh,
yes.
I just want to ask, in alternate way, can we use some statistical tools to justify the values that it
No,
is
no,
not
no,
good?
no, no, no. Because statistical, because your material is one material, and your lab has only done this one, and uh, you cannot ensure by using just a one standard, and by using one method only. If you have got different methods, then you use, because there may be some constraint in some cases, I can visualize,
Yeah.
because maybe your material which you are using, many the labs, maybe hardly any one or two lab may be available,
Yes.
sometimes
Yes, sir.
it happens. So in that case, you can means do intra laboratory comparison,
Yeah.
means if you have got one more than one labs of your same organization, you can go for inter-laboratory comparison, or
Okay.
with different methods, or with the different
Person.
techniques.
Yeah.
So, yeah, with different persons, with different this one, or by using uh, you can say replicate testing, retesting, and so these are all, you can say, by ensuring the validity of results that we have already covered in 17025, by using various techniques. So this is also one of the this one by which you can use your standard, can make your as a reference standard uh, if it is not available nationally or internationally. That is allowed
Yeah.
when such type of constraints are there. So, but you have to uh, have documented all these things to
Okay, sir.
show, yes, you have the capability, and you have ensured its value by using various techniques or various methods, and by using various replicates, retesting, and by using that techniques which can give the same results. So that is also one of the method you can make your standard. Yes.
Understood, sir. Understood. Thank you. And second question is, sir, if I'm having accreditation to 17025, and if customer is not asking for NABL logo, is it
Yes.
mandatory that all the time that I test and I have to provide NABL logo over the test report, or it is up to customer?
No, it is up to the customer, because customer, if customer doesn't want, then don't give. uh, it is not but it is always preferably to give the logo, because that will ensure that this certificate then it is acceptable wherever the customer will send. They will come to know, yes, the laboratory from where this product is tested is accredited lab.
Accredited. Yeah.
It has more edge than without logo.
Yes.
Because
Yes, sir.
I don't think no customer will say no, you don't apply any logo. Because rather they advertise. The customer wants to advertise that their product is tested from a accredited laboratory.
Yes. Yes,
So
sir. Understood.
rather than this one. So, and it is up to the accreditation body also policy, because if accreditation body says yes, you have to apply this one, but uh, it is the other way. If you are accredited, if you are not accredited for that particular scope and you
Then
are
we can.
using logo in place, then it is a you can say violation.
Yes.
It is
Yes.
the other way.
Yeah.
And you have given it to the customer, because customer doesn't know what is your scope, but you
Yes.
have provided, then it is a violation. Then, but if you are providing, I think it is a plus point for the lab and for the customer both.
Okay, sir. Understood. Thank you. Thank you so
Yes,
much.
yes.
I think there is a one more query in chat box. Mr. Dhruve someone has asked how to define tolerance in-house measurement of uncertainty for instrument.
Just a minute. Let me see. Tolerance in-house measurement. So this is I think a case of the calibration lab you are talking about.
Mr.
Hello.
Bhupes, you can unmute yourself also. Mr. Bhuvnes, are you there? Yeah, Mr. Krishnamurthy. I think this is not much clear.
Yeah,
John
it
sir,
is not clear. But
it's
regarding this question, actually, for further tolerance and other things, you have to consult more this ISO guide. This ISO guide 99 is there. Then for measurement uncertainty, guides are ISO guides are also there. So you have to consult that one. So I cannot describe this thing just in a, you can say, 1 minute or 2 minutes, because these are certain complicated things which needs to be statistically defined. So you have to further consult the ISO guides are available regarding uh, defining the tolerance of the uncertainty measurements of the instruments. ISO guide 99 is there for this one, and various other ISO, I don't remember the names. So they are available. So you can have to consult those guides, which will give you uh, all these statistical details.
Krishnamurthy. I think it's not audible. Sir, can you able to hear Mr. Krishnamurthy?
No,
You can drop into the chat box also your query. We will address the same. Any other person have query? In meantime, I think we can have one group photograph. I request everyone to please switch on your camera so we can have one group photograph also. Mr. Cecil Kumar, Dharmendra, Ms. Jyoti, Ankit Maurya, Dhruvi, Nilesh, Maitri Nayak, Ms. Harshita. Okay, so everyone is ready. Please smile. Thank you. Sir Krishnamurthy has dropped into the chat box. We have applied for the parameter like retention on one save can be given to the report as a retention of one save.
The report is retained on save. Parameter like retention on save. Can we give the report as retained on save? MOU frequency, ILC, frequency. Yeah, you can give, but you have to write in your report, test report, as per the requirement of the specification. Whatever the specification has written, whether they have written in the like retention on the sieve or retained on sieve, I think it is the same thing, but the wording depends on the specification of the product which you are testing. Because many times uh, the agency which is receiving the report, they just go word by word of the specification. So it's better you use the same word which is written in the specification rather using your own wording. So that will be a better way of giving in the test report. But I think for the sieving, the metal powders, dealing with metal powders, difficult to get CRM as they get eliminated. I think for that CRM, if they are not available, you just consult NPL, because maybe NPL might be having, because they are in this field. They are developed many CRMs of such type of material. I think you can consult NPL. Go there and discuss with the respective section who are dealing with such type of CRMs. I think you may get some help from NPL. And there is one question, MOU frequency, just a minute, ILC frequency and PT test frequency. So regarding this one, Mr. Amrish Chandra, the frequency depends on the lab, their own schedule, their own program. The lab has to make their own program of ILC and PT depending on the number of products and their participation, because you have to make at least 4-year PT program wherever the PT is available. If the PT is not available, then you make a ILC program, and you have to participate for all the parameters once in 4 year, whether it is PT or ILC. Regarding the MOU frequency, that depends on whenever there is change in the calibration of the equipment or of the CRMs or of the place of working, if there is any shifting of the instrument or the calibration status has changed, it has been recalibrated, or of the method change, then you have to recalculate measurement uncertainty. So these are the, there is nothing frequency but requirement. for recalculating the MOU. Whenever there is change in the calibration, there is change in the instrument, change of method, change of environmental conditions, or change of place, working place. So you have to do all these things. So whether the class of weights changes if we are not using the master weights calibration, for example, E1 to E2. No, I do not understand because if you are a testing lab or you are a calibration lab, if you are a calibration lab, you have to use a higher level of weights, at least E1 or E2. And if you are testing lab, you can use slightly lower this F1 or F2. So that is the requirement. Because for calibration lab, it should use of higher level.
So any other person have query, or should we wrap today's session? Okay, if you people have not any query and doubts, so I have dropped one Google form link. Whatever your feedback, or if you have a query related to the accreditation process, you may reach to us, and you can also submit through the Google form also. So thank you everyone. Thanks for your active participation, and thanks Nizam sir for your valuable.
Okay, thank you.
Thank you everyone.
Yes, sir. Thank you, sir.